Okay, so now let's go into just practicing writing out proofs and filling out all of those reasons to justify each step. So here I'm given that AB is perpendicular to BC and DC is perpendicular to BC. And so again, remember this sign here, that just means perpendicular. So my first step is to go ahead and write my given information. So I'm going to go ahead and write them in two different steps. So I have AB is perpendicular to BC, and also have that DC is perpendicular to BC. So again, both of those are given. Now I'm looking at what I'm trying to prove. I'm trying to prove that angle B is congruent to angle C. And so now I need to fill out those reasons. So my first step here is I need to remember what it means for something to be perpendicular. And we'll see it's actually written in this diagram here. I see AB is perpendicular to BC, and they put this red box right here. So that means that this forms a right angle. Because remember, definition of perpendicular means that they intersect at a right angle. And same thing with DC and BC. So what I can say, since they are perpendicular, I can then say that that means that angle B is a right angle. And angle C is a right angle. And again, that's marked in my diagram also here. And why can I say that? Well, both of those, that's because that's the definition of perpendicular. When two lines are perpendicular, that means they intersect at a right angle. And so it's handy to have these definitions on hand. You'll notice before this, I did have all of those proof reasons written out for you. Definitely keep that on hand when you're going through proofs, because that can really help you determine what step to make next. Okay, and then I'm able to say after that angle B is congruent to angle C. Why am I able to say that? Well, if you recall from our last lesson, we learned that if two angles are right angles, we can then say that they're congruent to each other, and that was my right angle congruence theorem. And I do a lot of shorthand here just to fill everything out, but that just says right angle congruence theorem. Okay, let's look at another one. So here I'm given that angle 1 is congruent to angle 4, and I want to prove that angle 2 is congruent to angle 3. So I have angle 1 is congruent to angle 4. That's what I'm given. I want to somehow get to that angle 2 is congruent to angle 3. And so I can first mark in my diagram angle 1 is congruent to angle 4. And I'm going to put little arc marks there. So now I need to look at this diagram and think, okay, what else can I grab from this? Because I don't have any definitions to work with in my given, so I need to see what can I get from this diagram. Well, I noticed I have two pairs of vertical angles. I have angle 1 and angle 2 are vertical angles, and angle 3 and angle 4 are vertical angles. So I'm going to go ahead and write that. That's just definition of vertical angles. Well, what did we learn about vertical angles in our last lesson? We learned from the vertical angles congruence theorem that means that they're congruent to each other. So I have that angle 1 is congruent to angle 2, and that angle 3 is congruent to angle 4. Again, that was my vertical angles congruence theorem. So now I need to somehow get, for one more step, that will lead to angle 2 is congruent to angle 3. I can't use transitive property yet because these are both different angles. However, I have that angle 1 is congruent to angle 4. So that means I can replace this angle 3 is congruent to angle 4. Since angle 1 is also congruent to angle 4, I can then say that angle 1 is congruent to angle 3. And I can use my transitive property there. And now, since angle 1 is congruent to angle 2 and angle 1 is also congruent to angle 3, I can then say that angle 2 is congruent to angle 3 using the transitive property again.